Good afternoon, everyone. It's my first time here, so I will not be taking any difficult question. And I'll try to make this as light as possible. I know it's late, and we've heard a lot about plastic and steel for the past 7 hours or so. So the first thing I want to say is that for me, I'm kind of new to this type of materials, but for me, steel is not the enemy. And I think one of the mistakes we make sometimes, like pushing for GFRP, is that we are pushing on and hitting steel instead of trying to promote and make sure that more people use the material for its properties. It's not GFRP, and I'm not saying this because you're here, Salem. GFRP is not better. GFRP is just different. So the more we know about it and the more we get testimonials, the more people will adopt it. But if we keep hitting the steel will fight back, and then we are fighting amongst ourselves instead of promoting something better. Okay, so I don't know who of you is familiar with Dextra, but been around for about 40 years. And the reason I'm saying that steel is not the enemy is also because we manufacture steel products, right? I mean, I would be lying if I wouldn't say so. So yes, we manufacture in China, we manufacture in India. And also one of the misconceptions is that products that are made in Asia are, low quality, you can trade them, you can trust them. That's not true. I mean, we all know now that in Asia, the level of automation in some factories is way beyond what you can find in North America, but vice versa, you find low quality products. So let's get those prejudices out of the way. Some of the figures about how many, this is, so I'm gonna push for, I will not be using imperial units during this presentation, and I hope that's okay. So I'll be talking about meters and about square meters and square kilometers. So this is 8 million linear meters of FRP produced in China, 3.4 million in India. That was for last year. So one of the mistakes, I think and we are guilty, as I mentioned this morning with Richard, is that when we initially promoted GFRP as Dextra, we promoted it as something that is temporary, can be cut, and can be disposed of fairly easily. And now we're trying to say that it's the best thing for bridges. So we have to adapt a little bit our dialogue. The reason is, so the first application, our application for GFRP was used in the tunneling industry. I don't know how many of you are familiar with the tunneling industry. But when a big machine goes into a station box, or in or out, breaking it or breaking out, we're going through steel. That's not the way the machine was designed. So this was actually making people lose quite a bit of time on their project because they had to cut the reinforcement within the concrete before the tunneling machine could break out. So that's not something that is very practical. So in 1996, we promoted with the contractor, and again, we are all engineers, I'm an engineer, but this is not only an engineer, it's contractors, engineers, owners, and we all have to try to row in the same direction. So this was the first time a soft eye was installed. Now, today, it's every tunnel project has a soft eye. So we're like, why aren't we using more GFRP? It's gonna make its way through. So we just maybe have to be a bit more patient. We're here to push it harder. But in that case now, it's common practice. Okay, so this is just the way we did it originally, and we promoted, and again, I'm sorry it's not directly for slabs, but you'll get your slabs later, I promise. The other thing is that we are now using GFRP for additional geotechnical. In the geotechnical world, in mining, it's used very, very, very commonly, and now we have been using it also with tiebacks, which can be an issue in some cities to have steel strand staying in the ground for after the project is completed, and then a micro-tunneling machine arrives or a piling rig arrives, and then it's a disaster. And then the liability, and everyone starts pointing fingers at each other. So once again, GFRP can be used for many different things. Okay, we're going to be talking about slabs. So I am not a slab structural engineer. I got my master's 22 years ago, and I haven't calculated a slab in 22 years. So please, no difficult questions about that. But before that, okay, so we've seen a lot of comparison GFRP versus steel. So GFRP is not stronger than steel. GFRP has different properties. It has higher tensile strength, but we know that shear forces can be an issue. In seismic environment, we know that given its brittle and non-ductile properties, we cannot be using it there. But in terms of lifespan, as we have been discussing, and obviously we don't have 50 years of knowledge about how bridges would behave with GFRP reinforcement, but as Doctor was saying before, we have 25 years now of GFRP in Toronto in some of those bridges, and no major issue. So for an owner, this should be a no-brainer. If I have a structure that can last twice longer, then that means that my capex cost in 50 years is going to be 100% instead of being it in 100 years. So that's something to remember. In terms of cost, again, this is very generic. This is not valid in every country, especially today with the tariffs changing the cost of everything every day. But this is roughly an order of magnitude of how much you would pay for GFRP versus black steel versus stainless steel. We're going to be talking about a few of those other advantages. So this is a project in Saudi Arabia. We know that Saudi Arabia has been pushing a lot for GFRP application. So this is for a 50 square kilometer park. That's huge for those of you who don't know what a square kilometer is. And there was different applications. So there were slabs that were outside, and there were slabs that were inside manufacturing sheds. But this is a very big push for the Kingdom of Saudi Arabia to get more and more tech companies, to get energy, to get greener, to get a lot of people coming, and they're building using GFRP for the reason I'm going to be highlighting later. So when we say about, we have to change is painful. So whenever we want to convince an owner, we usually have to convince about 9, 10 people, depending on how many engineers are on the site, and it only takes one person to say no for things to go to waste. So we have to make sure that we talk the language of every different stakeholder to make sure they understand the advantages of the product, and not saying, "Oh, it's greener." No, I mean that's what is interesting for you, and how I'm going to push for it. So these were the different areas of the project. So most of the areas were within. Like in warehouses, and so the loads were not that high, but there was a big area that was outside. The container stacking area where big forklift and a crane on rails would be installed. So originally the design was with epoxy coated rebar, grade 80, and you can see the loads applied to this slab. So this is, I don't know who Jim this morning was saying, is this a structural slab? Yes, this is a structural slab. I'm going to be talking about what we did to convince the client. So the first time is that we were involved very early on with the owner to talk about how much would it cost the owner to maintain the project once the contractor is gone. And that's something that the contractor doesn't care about, or the engineer doesn't care about that much, but the owner cares about it a lot. So having this conversation very early on with the owner would pave the way for the owner to push the engineer, and the engineer to push the contractor or work with the contractor. So the owner is a key component of this, because this speaks to the owner. Like, in how many years would I have to maintain, and what type of maintenance would I have to do? In lead time, in that case, well, we produce 3 million linear meters in a little over 4 weeks, plus shipping from China. So that's a lot. That's a lot of production. We actually set up a factory now in Saudi Arabia. Once again, with steel, you might not have availability of the product. In that case, one of the advantages is that you can build a protrusion line relatively easily. Don't look at me like this, Bernard. Compared to a steel mill. Again, in terms of cost savings, and I'm just talking about the pure material cost savings, that doesn't factor in the labor saving that we've been discussing today. Roughly, this was the overall saving. Once again, it's not a one-to-one saving. Obviously, you'll see later that the amount of GFRP rebar and the case studies and the load cases, so it's not something that you can take and say, I'm going to save 20%. It's project by project. Criteria. So this is, we played a lot with, you said rainbow colors, you like rainbow colors. We also like to play with rainbow colors. And the thing is that those were, you can't imagine on a container stacking area how many load cases you can have, depending on where the forklift is, depending on where he's stacking the container, and where he is at any given time. So thankfully, computers and not manual calculation is now available. So we made our own finite element analysis. That's something also that if we can encourage, because it's new, it's still new for some people, like having engineering capabilities within the GFRP fabricators and manufacturers is critical, so we can help the designers. Because change is painful, and if an engineer has never seen it, well, as Richard was saying, what is this? The same reaction for the contractor on the field, the engineer will have it. So having engineering capabilities in-house helps a lot having this conversation, so they don't think we're just trying to sell them, I don't know, a carpet or a curtain or something. So this was checked with more than 150 simulation with settlement bending moment, crack width, bearing pressure, shear creep, etc., etc. We spent about 8 months running all the analysis. So that's one of the problems, where when you want to change something, you say, no, I cannot change my design, it's too late. So that's why, once again, getting early on with the owner was key in that case. This is what we ended up with. So a big slab, that's 350 millimeters. So that's over a foot. And that is number 7 bar grade 45 in that case. And we did the calculation, the engineer approved it, and we made it using the guidance and the guidelines available to us today in 440. Okay, durability. Yes, well, this, again, that's a no-brainer. If you have to replace a structure, in that case, there were like tight requirements in the project in terms of how much the owner was willing to spend for maintenance, and getting that conversation with him went a long way. Like, I lead you read some of the capex and some of the future expenditure that the owner will have to ensure. That doesn't take into consideration if the operations of the container stacking area has to stop. That is where the money goes away. So once again, having those conversations, showing the owner what he can save was critical. Again, we all know that. I'm not going to do the marketing thing about non-conductive. We know those properties, but the one I want to go over on. Yeah, so again, durability, right? Are there studies? So we run our own studies, and again, if fabricators, manufacturers, engineering, and universities can start having more and more data, the more data we have, the more we can challenge the status quo, and some of those code requirements that we know are outdated and are not what we need today. So in this case, we did experiments we extrapolated the 5,000 hours. We only did the studies for 3 months, and then we extrapolated, and we could see that in alkaline environment and saline, we tried to reproduce what the concrete pH would do to the bars. We would lose 20% roughly of our tensile properties in this case over the long term, but then we would see a asymptotic behavior in that case. So yes, the concrete has an impact on the durability of GFRP, but we just have to make sure that we understand what it is and what is in that case, the reduction factor. Okay, so this, you don't have to see all this slide, but more and more we live in a world where there are waves everywhere, radar waves, Wi-Fi waves, RFID waves, radio, and the more waves around and the more steel around, the more potential impact on those signals. So you see more and more in that case, in those port and container area, where you have a detection of a truck, where you have something is scanned, etc. This can be impacted by the cage and the amount of steel in the slab. Plus, on top of that, it's very difficult to model. Very hard to say today, depending on the spacing of the steel, depending on the cover, depending on where the driver is, you would have an impact that can be very different. So modeling it is very hard. So in that case, GFRP rebar makes a big difference. It's used a lot in hospitals, as we know, because it doesn't interact with the MRI wave. So that's a tool that the engineer can use. And maybe on a building, you would have some steel in some parts and some GFRP in others. Actually, it's very, very common to do this in the tunneling and geotechnical industry, where you have in the face, you would have GFRP, and sometimes on the crown, you would have steel. So that was a project, I think it was in the UK, where you have those parking things that go up and down. Very annoying, especially when you click the button and it doesn't go down. Well, in that case, that was, again, an application of GFRP for this type of slabs. Okay, so a couple of things I'm going to show you. I don't want you to look at this one, but we talked about traceability. So I apologize, but I'm not a Gen Z. So I tried to download an Instagram video. I don't know if you've tried to do that. It's impossible. So I recorded it with another phone. So that is a testimonial from a client, I hope.
Drawbar carpet is...
Where's the sound? Okay, I'm just going to do something. Oh, no, it's not on. Okay.
Drawbar deformed bars are like...
Okay, I'm going to make it a bit higher. So this is a client of us in Australia. So we were saying how important contractors' feedback is, and how contractors, when they start using this product, they don't go back. That's our product, which is...
Together at pre-tied centres, being able to just kind of grab one part of the bar, pull it out 10 metres, lay another section straight over and pull it out, and all the bars are all kind of pre-tied straight to where they need to be.
So this is a product that we developed last year when we pre-tie the GFRP bars in one direction. So they actually come in bundles. And we were saying earlier that...
It's just all about speeding up the reinforcement process, eliminating wastage of materials.
We had about a 25% reduction in labor cost compared to the 30% reduction. I don't know, Richard, you mentioned 20 to 30% reduction in labor cost. That's the next step in terms of labor savings and how easy it can be to install GFRP bar on a slab, which is a similar application to the mesh that we've seen before. So how do we go the next step to make it even better for contractors to use it? This is, again, we're going to talk about in a minute, right? Okay, cool. Also about the carbon savings. And again, this is a very big conversation. So...
Drawbar carpet is...
Oh, okay. So the other thing that we have, so talking about the GFRP carpet, it's faster to install in two directions. It's approved. It has an ACC 521. Also, coupling two GFRP bars. As far as we know, there's been a lot of work and people trying to come up with a coupler for GFRP bars. Because we understand steel quite a bit, we think we have found a way. Actually, we've been using it. We swage a black steel coupler on the GFRP bar, and then we thread one bar with the other. So I'm going to have to take that phone whenever you... I'm just kidding. So this product can be used instead. We developed this product for geotechnical anchors because this little coupler here can withstand about 25 tons of tensile strength. Which is actually the limiting factor. With the swaging, we lose about 20% of the tensile strength capacity of the bar. But again, for the application we're talking about, it's plenty because we know that the tensile strength of the GFRP is not usually the deciding factor. So this product can also be used in stage construction for bridges. If you have a bridge where you have 2 lanes on one side, 2 lanes on the other side, today you have to cut 2 lanes plus something. So traffic-wise, for the user, it's not the best experience. So so the application are multiple, similar to application for steel couplers. And again, we discussed about the dowel bars earlier. There was a comment about GFRP cannot be bent, which is one of the shoe that how do you say that when you have a rock in your shoe, right, and you can't walk. Yeah. Exactly. So, but the truth is, there's been a lot of progress today, and some resins around the world are being developed to be able to, like thermoplastic resins, where you be able to bend the bar once you have it. So it is very still in the technology. It takes a long time, but in case of emergency, I mean, this will continue to evolve, and tomorrow it will be faster, cheaper to bend GFRP bars, which will take one of the rocks in our shoes in what we do today. And we'll also involve the rebar fabricator, which today is not involved at all in the cutting and bending because it's done at the fabricator. So we can understand that the steel people can say, I don't want to use, what I'm going to do with all my people, like to cut and bend rebar. So if they can cut and bend GFRP, maybe we'll have them on board as well. Okay, GFRP doors, we discussed that at length this morning. I'm not going to go over it, but it's another one of the applications. Okay, carbon footprint. This is a lie. Okay, I just want to say before I get questions. The first thing is, how is the steel produced? If it's recycled steel, it's 6 times less carbon footprint for production per, again, you talk about ton or do you talk about equivalent tensile strength? So there's a lot of talks in the GFRP is greener. No, GFRP is not greener. It depends what you compare it with. So again, compared to recycled steel, it's not. However, and that's something that is a big thing. If you add up the cost of transportation, again, comparing two bars that have similar properties, without going into too much detail. But the added cost of shipping because of the weight of the rebar can make a difference, even with recycled steel. In that case, we are like this one, if you include the Scope 2 emissions. And I encourage all of you also to publish your EPDs. So all our EPDs on, I don't know if everyone in the room has their EPDs, but this also goes a long way in terms of transparency, in terms of showing that we are honest. Other thing that we will see, that hopefully my kids, when they will see concrete in a few years, they're going to say, what kind of water did you use for this concrete? Fresh water? Well, you put fresh water in concrete, right? I mean, with scarcity of water and problems we have today, this is a committee in the ACI, the 243, that is pushing to use salt water, like seawater, to make concrete. We're not there yet. Obviously, steel would be an issue if you would steel in a like regular black steel with salty water. But with GFRP, we are actually studying the impact. And I'm sure that in California and Florida, in a few years, and I think in Florida they already built a bridge with seawater. I'm sure that in a few years will be, yes, most of the concrete in region that have no water will be using, and are close to the ocean, will be using salt water. Thank you very much.